Okay, here is your applying the remainder theorem video part 2. We're just going to skip over to the back of your note sheet and start with example 8. So the objective here is given one zero of a polynomial function, find the other zeros. Very, very similar to what we were doing on front. Here we're given the 0, 3, and on front we were given a factor. So on front we would have been given x minus 3, and we would have changed this into 3. When you're given the 0, and you're told that it's a 0, then that means when we plug it in, you should get a 0 as a remainder. So here's our factor that we're given, okay, and we just change the sign to get our factor, and you should remember that from when we solved. We're going to plug in positive 3, don't change the sign from this. Positive 3, and then we're going to put down our coefficients, and we should get a 0. And we do. And then we're left with this polynomial right here to solve and find the other zeros of x. And so there's multiple ways we can solve. Last unit we talked about several. We have completing the square, we have factoring, we have the quadratic formula. I'm going to go and try factoring first because that's just the quickest in my opinion. And then if factoring doesn't work, then we can try some of the other ways. Okay, so when we're factoring, since there's not a number in front of x squared, we're going to have x and x. And negative 20, two numbers that multiply together to give us negative 20, and positive 1 here would be positive 5 and negative 4. And so that's factored. And now if you remember, we have something times something, so this something times this something equals 0. That means that we have to set each one of those equal to 0. So we do that, and we're going to solve for x. So x equals negative 5, or x equals 4. So let's do another one. Example 9. All right, so we know the 0 is 4, so we're going to divide by 4. So we do that real quick. Okay, and we're left with x squared plus 5x plus 4, and we're going to set that equal to 0 and solve it. So once again, I'm going to try factoring. So two numbers that multiply to give us 4 and add to give us 5, so 1 and 4. And we're going to set both of those equal to 0. So we have x equals negative 1 and x equals negative 4. Let's try example 10. Okay, this one's worded just slightly different. Find the other zeros of f given that f of negative 2 equals 0. That just means x equals negative 2. Remember, f of this is function notation. It normally looks like this, but f of negative 2 means we're plugging negative 2 in for x. These are a typo. They should be powers. Okay, so we're plugging negative 2 in. And we're left with x squared plus 0x minus 9 equals 0. And so this is actually a special case factoring. We take the square root of x squared, that's x, and since 9 is a perfect square, we're looking for two numbers that multiply to give us negative 9 and add to give us 0, so we're going to have negative 3 and positive 3. So we set both of those equal to 0. We end up with positive 3 and negative 3 as our answers. Now, if factoring didn't work, you could use quadratic formula or completing the square, but we'll talk about that at a later time if necessary. Thank you.